Hi everyone, welcome to Algorithmist. So from today we shall start with the next pattern of our interview problems. So this pattern is the two-pointer approach. In the last series of videos we have seen about the sliding window approach. Now we shall move on to the next pattern, that is the two-pointer approach. So let us see what is this two-pointer approach and where it is used. So basically two pointer is nothing but we can say like we have two variables I and j which point to at two different locations and they do some manipulations. And then where it is used in problems where we deal with the sorted arrays or linked lists and need to find a set of elements that fulfill certain constraints. The two pointer approach becomes quite useful in such cases. In for sliding window, we have seen when we have to do something with sub arrays or contiguous arrays, we use the sliding window approach. So we use two pointer approach where we have something to deal with sorted arrays. So the keyword to note here is sorted arrays or linked lists and need to find some set of elements that fulfill certain constraints. So there the two pointer approach can be useful. The set of elements could be a pair, a triplet, or even a subarray. So without further more theory, let's try and understand this approach with a simple example. So this is our introductory example. This is called as the pair with the target sum. It's a very easy example. Let's see what the problem states. Given an array of sorted numbers and a target sum, find the pair whose sum is equal to the given target. So what it is saying is that we have been given a sorted array and we have given some sum. So we have to find two such number which add up to that sum. Okay, it's pretty simple. And what we have to return? We have to return the indices of those two numbers. Okay, fine. So let's see example one. So the input one is given as 1 to 6 here, 1, 2, 3, 4, and 6, and target is 6. So as we can see that the numbers 1 and 3, uh, the numbers are indices, that is 2 and 4. That is the index is suppose 1 and index is 3. Those add to the number 6. At index 1 we have the number 2 and at index 3 we have the number 4, right? So 2 plus 4 is 6. So the numbers at index 1 and 3 add to the given target value. So we have output 1 and 3. Now second example is 2, 5, 9 and 11 and the target is 11. Okay, so the numbers at index 0 and index 2, that is the number in index 0 is 2 and number at index 2 is 9. So those two numbers add to the total value 11. So we have written the index 0 and 2. So I hope with example you have got actually what the problem wants. The problem wants is we have been given a sorted array and from that we have to find two numbers such that their addition will give us the target sum. Okay, so let's see what are the possible solutions. Now I want you to stop the video or pause the video and think of some solutions. Then next move on to the next part of this video. Now the possible solution. Let's see. As usual, we shall start with the brute force approach. So for brute force approach, what we can do is we can take a number and we can find all possible pairs for that number, right? And then we can check that if those corresponding pair give up to our target sum, right? But that approach will take O of n square time, right? Because you need two loops for that. The outer loop will take the first number, the inner loop will take the second number, right? So that will take O of n square time. Can we do something better? Yes, we can do a bit better. Now, what we can do is after choosing the first number by using binary search, we can find another number based on what our sum is required. But even that will take n log n time, as n will be the time complexity to choose the first number and log n for the binary search. So total will be n log n. Now, can we do it in a more optimized way? Like in a linear scan, first we had n square approach, then we went to n log n. Now we want to do something better, that is big O of n. Yes, it is possible by using the two pointer approach. So what functionality we are going to exploit is here first is that first we know that our array is sorted, right? So can we use that to our advantage? First we'll think like how sorted array can be used to our advantage. See, so here we need to have one peculiar observation. That observation is that when we find a pair of a number that can generate the given sum, one of the number in the pair will be the smaller number and another pair will be the larger number, or in worst case, or at least they both will be equal, right? So that constraint is always satisfied. Like if you have to create the number 5, it will be like 1 and 4 or 2 and 3, right? So one of the number will be smaller and another number will be larger, right? And since the array is sorted, the smaller numbers will be at the beginning of the array and larger numbers will be at the end of the array, right? So what we can do is we can have pointers starting at both the ends, right? like the one pointing towards the start of the array and another pointing towards the end of the array. Why we are doing is that since a pair will comprise of one smaller and one larger number, we will move from both the ends, so that one end will visit all smaller numbers and another end will visit all larger numbers, and somewhere in the middle they will meet each other, right? So at each step what we are going to do is, if the numbers pointed by two pointers add up to the given sum, then we return their indices, right? If no, then there may be two conditions which may occur. What it is, if the current sum will be greater than the target sum. Yes, it is possible, right? If the numbers pointed by both the pointers, if we add them, then the sum might exceed the target sum. Yes, then what does it mean? It actually means that the exceeding sum is contributed to the larger number, right? Because if our sum is exceeding the target sum, then that exceed or whatever excess is there in the sum, that must be contributed by the larger number. So what we need to do is we need to reduce that number. So the only way to do that is take our pointer which is at the end of the array one step back. Yes, right. So why we are taking it one step back? As array is sorted, if we get one step back, we can get a smaller number, right? And also another case that can happen is if current sum is less than the target sum. Yes, it can happen that by the numbers pointed by two arrays, that their sum must be or might be less than the target sum. So that case might be due to the smaller number. That contribution might be due to smaller value. Hence, we need to increase our sum's value. So what we need to do is we need to move our pointer, which was at the start of the array, to the next value into the array. Why? Because since the array is sorted, if we move it to the next part of the array, we'll get the next larger number. So we shall keep repeating this process until we find a target sum or two pointers cross each other. I hope you got the algorithm. The algorithm is pretty simple. That is, start from the both ends of the array and check for the sum. If the sum is available, then we return the indices. If not, if our calculated sum is more than the target sum, we move our pointer which was at the end of the array one step back. Or if our current sum is less than the target sum, we move our pointer one step ahead, which was to the start of the array. So let's see this with the visualization so that it will become clear. See, this was the array 1, 2, 3, 4, and 6, and our target sum was 6. So our pointer 1 that was at the start of the array, and our pointer 2 that was at the end of the array, right? So now 1 plus 6, it is 7. That is, our current sum was greater than the target sum. Yes. So therefore, it was due to the major portion of the sum was contributed by the pointer which was pointing to the larger numbers, right? So what we need to do is we need to decrement our pointer so that we can reduce our sum. As we need to reduce our sum, we need to decrement our pointer, right? Why we are not incrementing the pointer 1? Because it will even increase the sum furthermore, right? Because see, 6 plus 1 is 7 and our current sum is exceeding. If we increment the pointer 1, it will do 6 plus 2 is 8. Yes, it will go on increasing the sum. So it is of no use. We want to reduce our sum as our current sum is less than the target sum, right? So what we are doing is now we are reducing the pointer. Now my pointer 1 is at 1 and my pointer 2 is at 4, right? Now I will check the sum again. Now my sum is 4 plus 1 is 5. Again, that sum is less than the target sum. Now what I want to do is, now I shall increment the pointer 1, because since my current sum is less, I want my sum to increase. Because if I shall decrease the pointer 2 once again, like 4 plus 1 is 5, then next time if I decrement the pointer to 3 plus 1 is 4, again my sum is going to decrease, right? So here you can observe that pattern is, if go on reducing my pointer 2, my sum will decrease, and if I go on increasing my pointer 1, my sum will increase. So whenever my current sum is less, I shall go on increasing. I want to increase my sum, I shall increment the pointer sum, also the starting pointer. And whenever my current sum is more, I want to decrease that sum, I shall reduce the end pointer, right? So here my sum is less and I want to increase my sum, so I shall increment my pointer 1. So now my pointer 1 is at 2 and my pointer 2 is at 4. Now the total sum here is 6, and that is what we wanted, so we return the indices as 2 and 4. So this was it, the basic introduction to the two pointer approach. And if you want to solve this problem, here is the link. I shall put this link in the description section also, the LeetCode problem. I wanted to pause this video, and now since you know the algorithm of how you can solve this problem, I wanted to go to this link, solve this problem, and come and check back the solution. So let's move on to the solution. So the solution is pretty simple. It's like hardly 5 to 6 lines of code. So first what I do is I sort the numbers, because if the number is sorted or not we don't know. First I sort the numbers. Even you can try without sorting. Then next is I initialize my pointers. I will be my starting pointer, so it is at the index 0. J will be my ending pointer, so it is at the end of the array. Now while I is less than equal to j, my current sum will be the addition of the two pointers, the numbers pointed by two pointers. If my current sum is the target, I shall return them. There in the question they wanted one base indexing, so finally I just added +1 to it. And if my current sum is less than the target, I want to increment my sum, so I will increase the I. Else it means my current sum is more than the target, so I need to decrement my higher value, so I will decrement the j. Finally, at the end of this loop we'll get our answer. So that's it for this introductory section. So from now on we shall be moving ahead with the two pointer pattern. So I hope if you have come till this far, you must be really enjoying the series. And if my series is really helping you, I want you to like, share and subscribe this channel, and I want you to share with as many people, as many friends as possible. Thank you.